In this board, this next 4 sessions, I'm experimenting a bit again. I'm now 65. My health is good. I expect to live another 30 odd years, hopefully. My father's 93 and nothing wrong with him. He may even get 100, literally. So, and I'm strongly committed. I want to be doing what I'm doing now, so generating YouTube lectures at graduate level, pure math and math physics, to help educate the alphas, people in the top percentile of IQ, the really valuable people of countries. And it'll be they in the third world countries who will push for democracy. So I feel strongly motivated to continue what I'm doing. But I do have one problem. It's my eyes. So to do what I do necessitates a lot of time looking at the computer screen, because I'm processing the movies, uploading them and so forth. But I've learned various tricks. I have soft lighting, and I think I use a large magnifying glass which literally doubles the size. It's a magnification ×2. It's very wide, as you can see, as you can compare. So I'm able to look at large areas. So that's very practical. I use that. But the remaining big problem is this: the damn lighting on the ceiling, which is the bulbs are too bright. Now I need, as soon as I get a check, I've got a check coming from America, I'll change the lighting, make it sort of muted and softer, so that I can have the light on and film. Now, so I've changed my routine somewhat. Now, so to have more daylight, I now clean the board from the previous day's filming and write up the new stuff. It takes a couple of hours because I have to understand what the text is saying, but still have enough time to film while there's still light. So we'll see how that goes, so that my eyes are not being damaged by the bright bulbs above, because my suspicion is that my peripheral vision on my retina are being damaged, and if this is happening regularly, there's not enough time for that damage to heal. It just progresses, may get worse, and if I keep it up, may even go partially blind, and that would be an absolute tragedy for somebody like me, because my life is books and ideas. That's what I do. It's what I am. Okay? So I label myself a sage. So a sage who cannot see. So it's the contradiction in terms, an oxymoron. Okay. So experiment I'm now doing is without the light. Life gets in the way. My Chinese wife has hung out the washing, and it's dry. We live in an apartment block, right? We're on the 7th floor, and so she's hung out the washing, which is now drying, on a clothesline that goes across the main windows, well, sliding doors in fact, because it's a balcony, onto a balcony, and those clothes are blocking out the light somewhat. So anyway, let's see how that goes. This is an experiment. Okay, so we're talking about regular expressions, and most of this board, 1, 2, 3. So three of the sessions of the 4 on this board are about regular expressions, and then the fourth board starts introducing that a regular expression and a finite automaton are actually equivalent, which might be a bit surprising, but that's like three sessions away. So most of this board will be on the topic of regular expressions, what they are in more detail, discussion about them, finer points about them, and so forth. Okay, so take a regular expression of this kind. Now, it's shorthand, so we've just got 0 union sign 1 in parentheses star sign. Now, strictly speaking, that is this, right? Because a union only is defined on sets. It's an operator that operates on sets. Okay, so 0 and 1 aren't sets, well, they're members of set. So you can rewrite this in a more formal way in the following way. Okay. Now the union of the set 0 with the set 1 is just the set 0, 1. Okay. You just add these two elements together. So that's pretty elementary from the definition of union of sets. So you get that, and then you star that set. Okay. So what's the result of that? So when I say what is the result of in the context of regular expressions, another way to say that in just one word, one verb, is to evaluate, right? To find the value of, in other words, to calculate out. All right. Well, if you evaluate this, what is it? Well, it's just the language that consists of all strings of zeros and ones. In other words, all possible binary strings. Okay, zeros and ones. So that's this. So this and this. Well, this is a kind of shorthand of this, and this is when you evaluate it, you get this, and you can evaluate it further and get the set of all possible binary strings. You set the string, all possible strings of zeros and ones. Okay. Now you can rewrite that slightly differently in terms of all possible binary strings. Here's an alphabet. It's the binary alphabet. It just consists of two members, 0 and 1. And so you can say that is actually shorthand for this. Right? Why is that? Well, because this is just this without the star. Okay? That's just this without the star. All right. Okay. Now, if sigma is just any alphabet, then you can look on that alphabet as a regular expression of what? Well, that regular expression would, its language would consist of all the strings of length 1. What does that mean? A string of length 1. It means it just has one symbol in it. A string of length n will have n contiguous, consecutive symbols in it, right? That's defined as the string's length. In other words, the number of symbols in the string. Right? Okay, so sigma star will be all possible strings, all strings of any length. Okay? That's from the definition of star. You just concatenate the members of the alphabet, right? So single symbols, as long as you like. You have all possible concatenations of the symbols of that alphabet. Right? That's what the alphabet sigma, capital sigma, star. That's what it means, right? Okay, so here's another, and that's a regular expression. Here's another regular expression, and you've now concatenated with 1. And that too is, let's see, that's also a shorthand, because see, there's an implicit, it's not there, but there's an implicitly, there's a little circle. It's sort of like saying, when you say AB, where A and B are numbers, what you're really saying is A times, with an X or an asterisk. Sorry, that's confusing. An X meaning multiplied by B, but often you just shorthand it to just AB. You leave out the multiplication sign. Okay. Well, here you've left out the little circle, meaning concatenate. Right. So this is shorthand for it's for a regular expression, and if you evaluate it, what would it be? Well, if sigma is, I don't know, is it the binary alphabet? Well, let's say it is. Let's say it's the binary alphabet. So sigma star would be all possible binary strings, and then you concatenate it with 1. Now, strictly speaking, you're concatenating it with the set that has one member, and that one member is 1, strictly speaking. Okay? And so the result would be all binary strings ending in 1. Now, if this sigma is not the binary string, just any string, then this would evaluate to all strings ending in 1, whatever the strings in this sigma star are. Okay. Now, what about this? We're just talking about regular expressions now, sort of getting more into the details of them and getting familiar with how to use them, because regular expressions are a very important tool in computer theory, computer science, and that'll become clearer and clearer as we get into these coming sessions. All right, how about this one? What's the regular expression? If you evaluate that, you get a set of strings, and that by definition is a language. So this regular expression, this one here, what language does it describe? Okay. Regular expressions generate languages, if you like. They're a description of languages, put it that way. Well, now it's a union. So this one would be the set of all strings beginning with a 0, okay? And this part here would be the set of all strings ending with a 1. Okay? So the whole, the union, would be the set of strings that start with a 0 or end with a 1. Okay? Yeah, start with a 0, end with a 1. Right. Now,